Now we're going to investigate some properties of logarithms. And as this says here, there are some results I can find on a calculator using the log button on the calculator. So when I look at that here, we see log 2 equals 0.301. Remember this log 2, that's log base 10 of 2, and we would find that using just the log button, the LOG button on our calculator. And so what we've got here, these 6 results are all results we could just get using the calculator and rounding to 3 decimal places. But if we look at that, there's some patterns here. If I look at the log of 6, that's 0.778. But that's the same thing I get if I take 0.301 plus 0.477, right? That's equal to 0.778. And that's just 0.301 is the log of 2. 0.477 is the log of 3. So the log of 6 is the same thing as the log of 2 plus the log of 3. Similarly, we can show that the log of 12 is the log of 3 plus the log of 4, or that the log of 12 is the log of 2 plus the log of 6. And of course, what we notice here then, when we look at this, 6 is 2 times 3, and it's log of 2 plus log of 3. 12 is 3 times 4, and it's the log of 3 plus the log of 4, or 12 is 2 times 6, and that's the log of 2 plus the log of 6. So when I look at that, that's where this product rule comes at below. So down here we've got the product rule. So in general it says if I have the log of m times n, that's just the log of m plus the log of n. Just like the log of 2 times 3 is the log of 2 plus the log of 3, or the log of 3 times 4 is the log of 3 plus the log of 4. The log of m times n is just the log of m plus the log of n. And like I say here then, as a sentence, we can say that the log of a product is the sum of the logs. We have other patterns just like this that work for subtraction or multiplication. So the log of 2 is the same thing as the log of 6 minus the log of 3. 6 divided by 3 is 2. The log of 4 is the log of 12 minus the log of 3. 12 divided by 3 is 4. So we get the quotient rule down here. In general, the log of m divided by n is just the log of m minus the log of n, or we say the log of a quotient is the difference of the logs. The final property we have is a power property. 4 is the same thing as 2 squared. And that becomes then the 2 times the log of 2. 8 is 2 to the third power. That becomes 3 times the log of 2. And so we get this last property. If I've got the log of something to the p power, that p can be brought down in front. And that's what's essentially happening here. That p comes down in front of the logarithm, which gives me that. And what we say then, the log of a number with an exponent is the product of the exponent and the log. So the exponent comes down in front and multiplies by the log. What we're going to see then is these properties of logarithms can be used, here's how I sort of say it, going from left to right, but also going from right to left. If we go from left to right, we're saying we're expanding this one log into separate logs. If I go from the right to left, we're condensing separate logs into one log. So what we want to look at then are some examples of how we use these properties to expand logarithmic expressions or condense logarithmic expressions. And I've got some examples that we can look at.